All right. Unit number 2 for biology. Here we go. Biochemistry. So this unit is going to deal with obviously this term biochemistry. So what is biochemistry? Basically, we're going to study the chemistry or the things that make up. Remember, bio means living. So the things are the chemistry of living things. So we got to study all these compounds that make us and make the living things around us. All right. So we're going to focus on a term called organic chemistry and organic compounds. Okay. And we're going to come back to this later in the unit, but just a little intro. There's 4 different organic compounds which make up living things. Okay. And you can see them listed right there: proteins, carbohydrates, lipids, nucleic acids. You've probably heard those terms before, like in the foods that you eat. You might have heard your mom or dad say, we need to get some carbohydrates in you to get you energy, proteins help you build muscles. Lipids are actually fats, and people often think that fats are bad, but actually fats are really good for you. Fats are necessary for life. And then nucleic acids, these are these things like DNA and RNA, which is our genetics. That's what makes you what you are, and that's why you look like, a little bit like mom and dad. We talked a tiny bit about that in our previous unit. So that's where we're heading. But before we go there, we got to review. If you remember, boy, you had this stuff in physical science last year, and you spent a whole semester on chemistry, the chemistry of things around us. So let's do a real quick review of that, and we're going to do some activities in class to help you with this as well. So first and foremost, we have atoms. Atoms we've talked about a bunch already in this class, and you talked about them a bunch already last year. Okay, all matter on Earth is made of atoms. Okay, really all matter in the universe. Of course, we can talk about the different states of matter, but we're not going to worry about that for our class. We're just worried about atoms. So what is an atom? It's the smallest thing of all matter. What's it made of? Well, let's see if you guys can remember. I bet you probably remember a nucleus. Okay, in the center of every atom is a nucleus, and the nucleus has you can see there a positive charge. I'm sorry, I keep moving my video, my face around. Has a positive charge because it's made of 2 things, protons and neutrons. And it has a positive charge because protons have a positive charge and neutrons have a neutral charge. So since there's protons that are positive and neutrons which are neutral, then the nucleus has a positive charge. Okay. Says they're both about the same size. We call it atomic mass unit. And that's, again, a review from last year. But basically, that's how we get the atomic mass on the periodic table. So we'll talk about that in a couple of slides. Then we have electrons. Well, these electrons are these tiny itty bitty things that circle the nucleus. And remember, from physical science, again, I'm going to keep saying that from physical science, it's basically they're in these electron clouds or energy levels around the nucleus. They don't circle in like really neat orbits like a lot of models would show. These things are really, really small, really, really tiny, way smaller than a proton or neutron. They have a charge of -1, right? So most of the time, the protons would equal the electrons, which would give our atom a neutral charge. I already said that, circles the nucleus and energy levels. Says they move so quickly within a cloud that it's impossible to know their location. And this is an analogy I give in physical science a lot, but they move so fast, it's kind of like if I saw a bike going down the road, I wouldn't be able to see all the individual spokes. It kind of looked like a blur going really, really fast. That's kind of like these electrons. These things are going so fast that a scientist can't just pinpoint where each electron is circling the nucleus. And then they're so small that their mass really doesn't matter. When I weigh the atomic mass of an element, of an atom, I don't even add in the amount of electrons. I only look at protons and neutrons because the electrons are so small. And we'll come back to that in a couple of slides. So what's an atom look like? Kind of looks like this. This is our Bohr model of an atom. And remember, this isn't really a truly accurate model because these electrons aren't going in this really nice, neat circles around the nucleus. But this is a way that we have used or a model that scientists have used to kind of depict what an atom looks like. So I have protons, these brown positive charges in the middle of the atom, in the nucleus. I have neutrons, those silver things. And then I have these blue things circling, those are electrons. Those are negatively charged. Continue with atoms. Remember that each element has a unique number of protons and electrons. That's how we identify them. Most of the time, atoms are going to be neutral. Why are they neutral? Because the protons equals the electrons. So therefore, if I have, let's say, 10 protons, which are positive charges, and 10 electrons, which are negative charges, well, that's 10 pluses plus 10 minuses. So that gives me a charge of 0. That gives me a neutral charge. There you go. The electron arrangement determines the bonds that can make. If you remember from physical science, we talked about these things called valence electrons, which are the electrons in the outer shell. We're going to look at those more in a couple slides when we talk about bonding. The atomic number on the periodic table, that equals the number of protons in an atom. And then we list, if you look at the periodic table, and I just looked up at my periodic table in my classroom, but we'll do that in class. They're listed in order by their atomic number. Okay, so for example, hydrogen is at the very top left of the periodic table. It has 1 proton. Okay, then I go all the way to the top right. It has 2 protons. If I change the number of protons, then I change the atom. The atomic mass, I add the protons and the neutrons together, and that number is also found on the periodic table. When you do the atomic mass, we're not going to add electrons in because these things are so small. The example I gave last year is like if I stepped on a scale and put a feather on my shoulder, would that add a lot of mass to me? Probably not, right? So the electrons are so stinking small that we don't even have to think about those with the mass when we're doing the atomic mass of an atom. Isotopes. We're not going to be real concerned with isotopes in this class, but it's a good review for you. Remember that isotopes are atoms with the same element that have a different number of neutrons. So that's why our number on the periodic table is a decimal, because that's an average of the most common types of that atom. And there you go. Sorry, get those things out of the way. So you see there it says if the on the periodic table it's the average atomic mass. That's why I have a decimal. But if you change the number of protons, you change the element. You can change electrons, that changes the charge. You can change neutrons, that changes the mass. If the protons of an atom changes, you no longer have that atom. If I have a hydrogen atom that has 1 proton and I add a proton to it, guess what? It's helium. It's no longer hydrogen. Okay, so the protons always have to stay the same for that atom to be considered the same element. So you guys remember this. Where are all these numbers? Well, I have the name, right? Hydrogen down there at the bottom. I have the symbol, the big H right in the middle for hydrogen. At the top, you'll find the atomic number, and that's where you can find it. And remember, the atomic number equals the number of protons. The atomic mass equals the number of protons plus neutrons. And remember, this is a decimal right here because I have averaged all of the different isotopes to give me the most common type of hydrogen. So there you go, a little review of atoms. In our next video, you'll see a little review of some bonding and how those things work.